Greetings. My name is Elizabeth Wade. I teach basic calculus in the mathematics department at Pellissippi State Technical Community College. This is topic 2 on derivatives and segment 2.4 on the product rule. The product rule for differentiation states that the derivative of the product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first function. Let's look at an example. Suppose that you wanted to find the derivative of the product of the functions x cubed minus x plus 2 and x to the fourth minus x squared. By the product rule, the derivative y prime would be the first function, x cubed minus x plus 2, multiplied by the derivative of the second function. The derivative of x to the fourth minus x squared is 4x to the third minus 2x. Then we add to this the second function, which is x to the fourth minus x squared, multiplied by the derivative of the first function, which would be 3x squared minus 1. Remember that the derivative of a constant, like 2, is 0. The next step would be to remove these parentheses by multiplication. So I'm going to multiply 4x to the third times x to the third. That would be 4x to the sixth. 4x to the third multiplied by minus x minus 4x to the fourth. 4x to the third times 2 plus 8x to the third. Continuing to multiply, minus 2x times x to the third is minus 2x to the fourth. Minus 2x times minus x is plus 2x squared. Minus 2x times positive 2 is minus 4x. On the right, 3x squared times x to the fourth is 3x to the sixth. 3x squared times minus x squared is minus 3x to the fourth. Minus 1 times minus x squared is plus x squared, and minus 1 times x to the fourth is minus x to the fourth. Collecting like terms, 4x to the sixth and 3x to the sixth is 7x to the sixth. I have minus 4x to the fourth, minus 2x to the fourth, and minus 3x to the fourth. And here's another minus 1x to the fourth. So that would be minus 10. Let me double check. 4, 6, 7, 8, 9, 10. Minus 10x to the fourth. Then we have plus 8x to the third. I believe that's the only term with x to the third. So plus 8x to the third. We have 2x squared and plus x squared, so that's plus 3x squared. And that leaves us with a minus 4x. So this expression is the derivative of the function y. Let's extend this by taking the same function, and let's determine an equation for the line tangent to this function when x is equal to 1. The first thing that we would have to do is to determine the point of tangency, where x is equal to 1. So to do that, we will take the original function and plug 1 in. So that would give us 1 to the third minus 1 plus 2, multiplied by 1 to the fourth minus 1 squared. Notice that in the second set of parentheses we have a 0, so that means that this product will be 0. So the point of tangency, x is 1, y would be 0. The second step would be to determine the slope of the tangent at x equal 1. To do this, we use the derivative of the original function. Well, we found using the product rule that the derivative of this function is this expression. So the slope at x equal 1 would be the derivative evaluated at 1. In this case, that would be 7 times 1 to the sixth minus 10 times 1 to the fourth plus 8 times 1 to the third plus 3 times 1 squared minus 4 times 1. If you do the required arithmetic, this comes out to give us a 4. So we know the point of tangency is 1, 0. We know the slope of the tangent is 4. Recall from algebra the two forms for writing an equation of a line. Y equal mx plus b, and y minus y sub 1 equal m times x minus x sub 1. This is the slope-intercept formula, and this is the point-slope formula. I'm going to use the first one, y equal mx plus b, to write the equation of this line. So y equal mx plus b. I have a point on the line, 1, 0, so I'll substitute that point in for x and y. I also know the slope of the line, which is 4. This allows me to find the value of b. So b would equal, carrying this 4 to the left side, b would equal negative 4. So now I have the equation of the tangent line. Using the form mx plus b, I know that the slope is 4, and I know that the b value at the point 1, 0 turns out to be minus 4. So the equation of the tangent line to this graph at x equal 1 is 4x minus 4. Let me show you a calculator trick. First, you would graph this function on your calculator in the viewing window under y equal by typing in the function, which I've already done, x to the third minus x plus 2 multiplied by x to the fourth minus x squared. Then I'm going to go to the Draw menu, which is located above Program on your calculator, Second, Draw. I'm going to go to number 5, Tangent. Let's go ahead and graph our function, and then let's go to the Draw menu. So Second, Draw, this will be faster, and then go to number 5, Tangent, and then all you have to do is type in x equal 1 and press Enter. And what your calculator does is it draws a tangent line to this graph at x equal 1, and notice that down at the bottom of the screen it gives you an equation of this tangent line. In this case I have y is equal to 4, and notice there's some decimal values here, minus 4, 4x minus 4. We obtained, using calculus, y equal 4x minus 4. The calculator feature does not give the exact same equation for the tangent line. However, it is very close. This is a limitation of the calculator. Calculus provides us with the exact answer. Well, that's it for this segment. Now you need to practice this concept by working similar problems. Good luck.